Alright, hello everyone. Welcome to today's lesson on graphing relations. So for the past few lessons, we learned about how to read graphs, how to understand graphs based on context. Alright, but today we're actually going to put the graphs onto paper. Alright, so one of the most common forms of graphs you will see will be in this form. And this is called the slope-intercept form. It's very, very useful because it gives you the two pieces of information you need to graph anything you want. Right, so it's always going to be in this form here. Right, so we have y here. Right, every single graphing equation you'll see will start with y, or most of them at least. Right, we got the y and the x. Right, that's our usual suspects. Right, but we have a number in front of the x. Right, that is what we call a slope, and a number tagged along at the end, which is the y-intercept, which we learned about already. Now the slope of a graph is the rise over the run. So, think of it as how much the y value changes over how much the x value changes as a fraction. That's pretty much our entire lesson today, right? So let's do examples. Right, we got our first one here, 3 over 4x minus 3. So, again, let's highlight the important parts of our equation here. Right, we know that right away. This minus 3, that's the y-intercept. And we also know that this right here, well, let's do it in green still. This number right here is the slope. I said the number in front of the x is the slope, and the number tagged along at the end is the y-intercept. Right, and with the slope, we got 3 here. That's our rise. And 4, that's our run. Right, so what this is telling us is that for every 3 units you go to the right, you also go up by, sorry, other way around. For every 4 units you go to the right, you go up by 3 units. Alright, so in practice, let's graph it out. Right, first of all, y-intercept, that's the easy part. The y-intercept is -3. So our first dot is right here. Y equals to -3. Right, and as remember, the rise is how much the y value changes. And we know it's +3. Right, so our y goes up by 3. So from this point here of -3, 1, 2, 3. Right, so we go up by 3 units. Next, we have the run. How much it changed by the x units. Right, and we have 4 here. So from that point, 1, 2, 3, 4, 4 units. And that's where our second dot is. Oops, why did I erase that? Second dot. And from there, you just connect the dots, and that's your graph. Alright, so make sure to use a ruler. Let's see, gonna get my ruler. Like that. Right, and as a good habit, we put arrows on both sides of this graph to denote that the line extends forever. Okay, and then that's it. Right, so as you can see here, from each dot, we go up by 3 and go to the right by 4. Right, we get to another point in this graph here. Right, so that's what the slope tells us. It pretty much tells us how much does it change between 2 points. Okay, let's try another question here. So right here, that's the y-intercept, +4. But right here, we have -3. Right, so remember, when we write fractions, right, if it's something over 1, we just essentially ignore it. Right, we don't really write -3 over 1, we just write -3. Because -3 divided by 1 is just -3. Right, and then we have rise and run. That's our rise, and that's our run. Right, so one thing to note here is that the run is always the run is always positive. There we go. Ugh. The run is always positive. Right, whereas the rise, that's the one where we determine if the y value goes up or goes down. Right, so the run is always along the positive x direction, and the y, depending on the sign, will go up or go down. So once again, we drop a dot here at the y-intercept, which is +4, +4 in this case. Next, let's do a rise. The rise here is telling us to go down by 3. So 1, 2, 3 down. Right, -3. And the run here is just 1. Right, so again, our slope is -3, which is just -3 over 1. 1. So that's our second dot right here. Okay, and again, we grab our ruler. Looks. This is a bit more precise here. That looks good enough. Right, that's our graph right here. Right, so you can see from this point we're going down by -3 and going to the right by 1. Right, going down by -3, going to the right by 1. Right, realistically, I'm not gonna check to make sure every single dot is correct. Right, I just want to see 2 dots. Right, one at the y-intercept and another dot that follows the slope. And then you just have to connect the 2 dots. Okay. Right, so this is a really fast way of just determining how to draw a line. Right, but we can also use the table of values. Right, so generally with table of values, you only need 2 numbers. Right, but we can do 3 just to be safe. Right, so we always start at x equals to 0. Right, that's our y-intercept, which is -3 for the first one. And now we can just plug in a few different x numbers and plot it onto the graph. Right, of course, right here we have 3 over 4x minus 3. Generally, for the x you want to plug in, I will just use a number that's easy to calculate with this equation here. Because we can definitely do, right, x equals to 1. Right, but with x equals to 1, so 3 over 4 times 1 minus 3, that's going to be a negative fraction. I don't want to deal with that. So what we can do is try to plug in x equals to 4. Because if x equals to 4, right, if x equals to 4, this will cancel out to get 0. Right, 3 over 4 times 4 minus 3. So 4 cancels out. So you got 3 minus 3, which is 0. Right, and then how about -4? Right, again, just making this equation easy to calculate for us. We could do 8 as well if you like. And -4. Plug in a -4 minus 3. Again, those will cancel out to be 1 and 1. So we got 3, or -3 minus 3, which is -6. Alright, so now that's our 3 points. Alright, so we already got 2 here. Alright, 1 at 4, x is 4, y is 0. 1 here at 0, x is 0, y is -3. The last point, -4, -6. Right here. Well, let's do it in the orange color here. Alright, so we could just do 3 dots and connect the line. Again, realistically, you can just do 2 dots if you want. Alright, but I'm doing 3 just in case. Careful any calculation errors. Because if the 3 points don't make a line, then that means we mess up on one of the small calculations. Okay, next one. Once again, if x is 0, then y is 4. That's the y-intercept. And now we can just do 1 and -1. Again, because it's easy to calculate. Alright, 1. -3 times 1 plus 4. -3 plus 4, which is just 1. If x is -1, that's +3 plus 4, which is 7. Right, so we got 0, 4, 1, 1, which is already here. And then we have -1 and 7. So up here. -1, 7. 3 dots, connect the line. Alright, but I encourage y'all to try to get used to the slope-intercept form. Because again, it's a lot faster. Right, we just need the y-intercept point, and the second point was the rise and run. Alright, so with our slope-intercept form, we can pretty much graph almost anything we want. Alright, so let's go back to our first lesson of the unit about finding patterns. Alright, so this pattern here, 3, 5, 7, 9. We know it goes up by 2 each time. Alright, so each of those numbers, we're multiplying by 2 each time. We know the first one, we just multiply by once. And then we go up from there. And to complete the equation, right, we add 1 to each of those 2 multiplications. And as you can see, the 1 doesn't change, we start at 1. So the only thing that does change is what number we're multiplying to the 2. So our equation is 2n plus 1. That's our equation. Alright, now let's graph this. What's our y-intercept? Right, y-intercept is at 0, 1. Right, that's the number that tags along at the end. What about the slope? It's just 2. Right, that's the number in front of our variable. Or in other words, it's 2 over 1. Alright, so every time we go 1 to the right, we're going up by 2. Okay, let's check it out. So y-intercept 1. Right, our slope, we go to the right by 1 and we go up by 2. That's our second point right here. Yeah, and then we're done. Right, we drop a ruler here. Gonna just line it up. Right, that's it. Nice, I'll just scan 2 pieces of information we need. The y-intercept, which is this number at the back. The slope, which is the number in front of the variable. And we can get the rise and run from that. Okay, how about some bigger numbers here? Right, so we got SSN here. It's a luxury cruise that charges $4 per ticket. But its starting cost to sail is $200. Right, so we want to know what the profit of this ship is. Alright, so now first step is find out the equation of this. Right, we know that our profit is starting in negatives. Alright, so the starting cost is $200. So that's the money that we need to not get rid of. That's the money that's in the negatives, right? Because it's costing us to make the ship sail. Because our goal is to find the profit. Right, so how much money did we earn? Right, so we know that the money earned. Right, the money earned here is $4 for every ticket. Right, $4 per ticket. And so the profit, right, is $4 per ticket. Let's just say 4 times n. N is number of tickets. Right, but we have a starting cost. Right, it costs us $200 to get this thing started. Right, so our profit is 4n minus 200. Right, because yes, we're earning 4 times n money. Right, n is the amount of tickets, but it costs 200 to run this whole thing. Right, so we have to take that into consideration when we're working with profit. Okay, and then from there, business as usual, right? Minus 200 is the y-intercept. And the slope, the number in front of a variable, which is this 4, or 4 over 1 more specifically. right? And now we can make a table for this, right? So what number do we start with? Right, so very important here, we actually start with 0, right? There's no negative numbers here because we're selling at least 0 tickets, right? We cannot sell -1 tickets. So we have to start at 0. So if n is 0, the profit will be -200. Right, so this is when we sell no tickets, but it costs us $200, $200 to start the ship. Okay, so we can do then 1 ticket, right? That's 4 minus 200, but that takes way too long. Right, for bigger numbers like this, we can just go up by 10 each time. Right, so after 10 tickets, it's 40. Right, 4 times 10 minus 200. Right, we can just go by 10 each time. Let's do one more. At 50 tickets, we finally hit 0. Okay. So now, the harder part. Let's graph this thing. So, we got our x and y axis, but in this case, remember our x-axis, or our n, right, we actually don't really need to worry about the negative numbers, right, because we cannot have a negative ticket. Right, so we can actually start our y graph here. And let's start somewhere in the middle here. Right, we can make our graph like this, because again, we actually don't really care about the negative numbers. We only care about the positive ones. Right, so our x-axis is the n, y is the p. Okay, we'll give it a title as usual. So, profit of SSN. Right, that's our little graph title here. And of course, on the side, we need to indicate what those axes mean. Right, so the P here stands for profit in dollars. And then the X here is the tickets sold. Okay, and now we have to put down the values, right? Of course, we know there's a 0 here. That's our origin. Right, so now how do we space it out? Right, we can space it out, because we cannot just do 1, 2, 3, 4 for each graph, for each grid, because we need to get to like 50. So what we notice here is that, again, with bigger numbers, we cannot just go by 1 each time. We have to fit all the useful information in this little grid space that we're given. Right, so let's see, how many grid spaces are there? It's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in total here, we got 12 grids to fit all of our numbers. And similarly here, 1, 2, 3, 4, 5, 6, 7. We got 7 grids here. Right, and notice how with our tail values, we went up by 10 each time. Right, because we went up by 10 each time, we have to go up by 10 within 12 grids. Right, and we notice here that we went up by 10 5 times, right? We're from 0 to 10, to 20, 30, 40, 50. So what we can do here is go up by 2 grids each time. Right, so you got 10, let's do in black here. 30, 40, 50. Right, so that's how we can kind of gauge how to space it out. Because we want to fit all the important information in there, but we're only given 12 grids. Right, so I mean, realistically, we could just do 0 to 100. Right, we could do that too, but it will be harder for us to plug numbers in between because I have to count the grids. Right, for profits, similarly, we went from -200 at the bottom, right, all the way to however many we want to go up to. Right, so let's say if it's 7 grids here, let's say -200 starts here. Right, because we can see that if we do it here, we'll divide it into 2 equal parts. Right, so negative 100 will be here. Right, so again, that's just how we gauge what the scale of this graph is. Right, so now we know on the y-axis for every 3 spaces we're going up by 100. Okay, last step is to plot them up. Right, so when n is 0, p is negative 200. So y-intercept. When n is 100, y is negative 160. Right, we know 150 is around here somewhere. And 50 is right here, because that's the middle of the 3 blocks. So 160 is somewhere around here-ish. Nope. It's negative, so it's somewhere below here-ish. 20, it's negative 120. Somewhere around here. 30 is negative 80. 40 is negative 40. And at 50, it's at 0. Okay, grab our ruler and graph this guy. Again, the dots are not entirely aligned, but as long as it's close enough. It's not very important here. Alright, we don't do an arrow on the other side here. Alright, we don't do an arrow here. Right? Because, again, we cannot go into negatives, right? We cannot sell negative tickets, so we have to start at 0. Okay, and then from here, how many guests have to purchase the tickets for it to break even? Right, so essentially, how many guests do we need so that the profit is 0? Right? Right, so we can look at here, right? If p is 0, the n is 50. We can also see on the graph here. Right, the moment we reach this point in our graph, the profit finally started becoming positive. Alright, so we started at negative 200 after 50 tickets. Now it's finally positive on that side. Of course, we can solve it with algebra too, right? If 0 equals to 4n minus 200, right? That's our original equation. Reverse order of our bed mass. So n is 50. But earlier we actually made a crucial mistake, right? For part E here, does it make sense to connect the dots? Right? Do we actually need to connect all the dots? Right? The answer here is actually no. Right? Technically, or not technically, actually, right? The graph actually doesn't make sense when we connect the dots. Because, right, we cannot have a ticket. Right? Because connecting the line here implies that, so in between, say, 0 and 10, we have 5. And in between then, we got like 7, 8, and all that. But in between then, we have all those numbers in between, right? We got things like, let's say here, this is probably around like 7.34. Right? A line implies that every single number on the x-axis has a value, which doesn't really make sense because you cannot have 7.34 a ticket. Right? So actually, it actually doesn't really make sense for us to connect the line here. Right? So that's something to watch out for. Right? I know that this is a lot more complicated. It's definitely more in the extending slash high proficient or extending side of things. Right? But the most important part of this lesson I want you to take away is how to graph something like this. As long as we know the number behind here, the constant, is the y-intercept, and the number in front of x is the slope, that's how you graph anything you want. Okay, so with that being said, good luck practicing.